Welcome to the stream. Welcome to All Around Azure. I'm Frank Boucher, your host. I'm a Microsoft Cloud Advocate, and today with me I have M, who's also a Cloud Advocate. In fact, we were the two only original Cloud Advocate in Canada for a week. And then I changed team and become global, and like everything just changed. But yeah, so both Canadian. But previously, I know you were from Berlin, but where are you? Were you born over there?
Originally from California. Yeah, I'm American, but I was living in Berlin for a while.
An American. Oh, nice. So anyway, do you want to introduce a little bit, tell a little bit more about yourself? Because I could try, but then I won't give it enough justice. You do so many things.
Yeah, for sure. So within the Cloud Advocacy team, I work on spatial computing and games because I have a long background in game design and working with sort of emerging technologies and new interfaces and new ways for people to interact with technology. So I make a lot of games that use non-traditional interfaces, which can mean everything from, virtual reality and audio interfaces like Alexa and Cortana and Google Home, to making a game played on an actual 1920s telephone switchboard where you're plugging cables in. That I sort of love this process of how can we take some piece of technology and figure out what sort of interactions work on it using play and game design and that sort of thing.
Yeah, I think you showed me the one with the cable or something like that. Was the old thing, and yeah, that was cool. Well, all the project. Every time you share a project, I'm like, oh, that look awesome.
That's what I hope for.
Like, you're good, because I think every time it's always like, oh, I need to try that. I need to dig into this. So, and what do you have planned for today?
Yeah. So speaking of weird projects I've made back when quarantine was just happening and we weren't really talking about masks, we were just talking about not touching your face. I figured, Microsoft has all of these really, really cool Azure cloud-based custom vision AI technologies. Can we use those to train a machine learning model that can detect if you're touching your face or not? And so I built this web app that does exactly that. It shows you a webcam view. If you're touching your face, it will play a loud sound at you, so you can stop doing that and sort of train yourself out of doing it. And I figured it would be fun to walk through. We're probably not going to get all the way to building the full complex app as it lives on the web, but talking about how can we build these sorts of machine learning models yourself as someone who doesn't really know how machine learning works and doesn't want to deal with the concept of training a model sounds really scary and it involves a lot of math, when in practice it actually doesn't.
Well, it sounds scary, like training AI. I don't know. You want to start by showing a demo of this app, and then we'll see the pieces? Okay, so we'll switch.
Yeah, totally. So yeah, and I'll turn off my video because it turns out computers are unhappy when you try to use the webcam for multiple things. Let me know when my screen should be live.
Your screen is live. It's mostly instantaneous.
Cool. So this is totally live. You can go to this exact same website at home.
We don't see it, but if you want to share it in our
I'll share it in the chat.
I will paste it in the.
Cool.
There's two Franks in the screen. That's a little bit scary. Definitely even
not advanced
more
enough
scarier than training something.
So yeah, here it is totally fine. I am happy, and then as soon as I touch my face, it yells at me and tells me not to.
Wonderful. This is cool.
Yep.
And you say we'll not build from scratch because there's a lot of code but the major pieces will be able to kind of do that today?
Yeah, so at the heart of this, there are really two different pieces to it. There is a machine learning model that given a photo or a webcam stream, it can tell, is there someone touching their face or not? And that's one piece. And then the other piece is hooking that up to a web app that has, all this text on it, and it plays an audio file, and it does all that stuff. And I think we're probably not going to touch the website stuff today. We'll see. But we'll get to a point where we have our own custom machine learning model that has been trained that we can give it an image and it will give us some results back.
I like the sound. I just realized the sound you picked.
We also have some other classics
from
like
the goose.
Yeah, the Untitled Goose Game.
Yeah.
Let me switch back to actually presenting video.
But JavaScript is also scary, Seth. Seth is saying that AI is not scary. It's just choosing the JavaScript. It's just choosing a JavaScript framework. But JavaScript is also scary. I don't know JavaScript. I start learning it recently.
Yeah, that's a really good point. I've been writing JavaScript for many, many years. So to me, it's just the tool that I reach for.
Yeah. Well, like, I used to know JavaScript, but I didn't code any JavaScript for the past... I think I calculated the other day on my stream, and I think it was about 15 years or something like that. So somewhere between 15 and 20 years. Back in the day where jQuery was like the craziest thing you could do. I was building a little game for to help my daughter study maths.
Nice. Is my video feed not working for some reason?
You're still...
I'm going to turn it off and on again.
Super blue.
Yeah, my webcam is not even... My webcam is not turned on. Interesting.
Maybe you can...
Oh. There we go. Maybe. Is anyone here good with computers?
Not on my
it turned off again.
Well, you could try to leave the call and come back.
Cool.
I will stay here. I will chat with the. I will chat
Hold
with
down
the
the
chat.
fort.
Should answer, right?
Hello.
Hello. And back you are.
And, hey,
Yay.
beautiful.
Oh, I have a sound effect. I should try that. Will it work? Will it work?
Yay!
They are far. I should bring them in my stream deck closer. Okay, so let's back to your screen. Now let's continue.
Yeah.
Cool. Oh, like it's even all on GitHub, so people could really have fun with that.
Yeah, I also have this is all the code that exists that is live is on GitHub. I also have a really nice Medium post I think you'll post a link to later that walks through like the technique that I'm going to walk you through today isn't actually what I ended up using for the full site. There is sort of a path of trial and error of the many different ways you can build the sort of model, which one is actually going to work the best for your use case. So the one that we're going to be walking through today is sort of the easiest, fastest one to get to work. But okay. I talk a bit about what are the challenges to actually releasing it as a thing that anyone can use on the internet.
Awesome. And inside your post, there's a link to GitHub?
Yeah.
Okay,
yeah.
So I will share your blog post and from there people could dig into the code if they are interested.
Yeah.
I just posted in the chat. Cool.
Oh, I think that is the app itself. That is not the the blog post. Also, if you link to the GitHub repo, there's a link to the blog post from there. Anyway.
So is don't touch your face right up?
That sounds right. Yeah.
Okay.
If it looks like a short link.
Yeah. Can I remove that one? No. Okay. Anyway, so a bunch of links.
Yep,
yeah, I
everything.
just realized it's the same link I pasted just before. Cool.
Yeah.
So where do we start?
So let's start by talking about
custom.
Yeah, let's talk about custom vision and what it is.
Yes.
So if you think about training a machine learning model, like maybe you're imagining like a bunch of text files and a command line and like tuning parameters. Custom vision isn't that. It is a sort of web UI where you can upload a whole bunch of images and then classify them in different ways, and that will sort of train the machine learning model, like these types of images correspond to this different tag, so that then like if we then give it our own image of, say, a person touching their face or not touching their face, it will have already trained that model based on these previously given images to try to do that. So what I'm going to show you really briefly, but we're not actually going to bother running the code. One of our colleagues, Cassie, who I think you're going to have on the show later this week or next week, she put together this script that basically goes to the Bing image search API. And it lets you specify here a bunch of different keywords I want images for, and it downloads a whole bunch of images for those and dumps them in a folder. Like looking at this code isn't that helpful. It is some JavaScript code that makes some HTTP requests. But the result of this that I already ran is we have 2 different folders of images, one called face and one called touching face. So if we go to touching face and we look at our training data, we see a whole bunch of photos of people touching their faces. Like this data set is not perfect. You can see it is mostly white people. This likely is going to lead to some bias. That is something that if we are building the larger version of this, we would want to deeply look into and make sure that we're building something inclusive. But for the sake of a quick demo, it is probably okay. And then similarly for just faces, we have a whole bunch of photos of people's faces. And so if you wanted
to pause just a second, because you say, okay, this is Azure Custom Vision, and you show a web page, but is it like, can I just arrive at that web page and it will be available? I'm assuming I should create some kind of service. Is it part of the Azure?
I don't remember exactly how this works. I'm pretty sure
we don't see the URL. It's under the title of the show right now.
Oh, okay. So it is customvision.ai. And so I believe you don't assuming you already have an Azure account, you will need an Azure account in order to log in. But once you have an Azure account, all you do is when you go to create a new project, you will need to attach it to a resource. So if we say this project is going to be like face demo, and we can create a new resource for it. We'll call it face demo.
Okay, so this interface will go and create whatever it needs in Azure, in your Azure subscription.
Yeah, you don't need to touch the Azure portal at all. This handles everything. So we're going to go and assign it that. We can create a new resource group while we're at it. Why not? This has a free tier. I think we can't choose the free tier because I'm already using it on a different project, or there may be some restrictions there.
Yeah, with free tier, usually you have only one or something like that. Otherwise,
but otherwise, for building something like this, the only one of the large differences between the free tiers and the paid tiers is how many different iterations you're allowed to do when you're training the model, which for our purposes is totally fine. You can also go in and delete earlier iterations to free up space. So for the production version of the site, that is also just using the free tier. That is probably even the free tier that I'm already using.
Okay. So then it create the resources. So if we go in the Azure portal, we'll see all the resources that was created. We could assign a budget or to make sure we respect using the free tier. So it's free. It might maybe some storage we'll pay for or something like that, or it's totally free. Do you know?
I think it is totally free, but do not quote me on that. At least I'm not aware of it creating.
If it's only few images in the storage.
Oh yeah, then it's not going to particularly matter anyway. Yeah.
Storage is very, very not expensive. Okay, so create the resource, but you still have access if you want to dig to it and learn more. And so I'm assuming through Azure CLI and Azure PowerShell and all the commands, you could question that and be able to script that to reproduce it without going and filling that environment. Okay, that's pretty cool.
And I've also seen we're not going to talk today about it, but sort of the version that is running on the website, there is sort of a separate web tool that lets users upload their own images to help train it, and that is a project that Seth, one of our other colleagues, built. And all the scripts to set that up are actually creating all the custom vision resources using the API and the CLI, so it is possible to script all of this as well.
Okay, cool. Well, I like the fact that like if you just want to play with the custom vision, like you don't need to think about what kind of resource you need, and everything is just done for you. And
Yeah,
it's different.
really nice.
Like it's a little bit more advanced version, because there's another one that I know, part of the cognitive services, and the cognitive services, those are API available inside Azure. There's the Vision API, but that's really a black box. You cannot train that one. Like it works like that. This one, you can train it, and like it looked very simple with just like simple of images. That's pretty cool.
Yeah, and I suspect under the hood, this is probably using a lot of the Vision API stuff. Sort of the reason this works so well, and the reason we're going to be able to give it 20 images or 30 images and get a functioning model out, is because it is not just training a model from scratch with these images. It is taking this gigantic machine learning computer vision model it already has, and it's saying, great, given all of the stuff we've already trained, let's just sub-train it a little more to give it more context. So that is why
finishing the training.
Yeah, exactly.
Oh yeah, it makes sense. So the model kind of figure already, okay, that's a phase, that's an end, whatever. Like, I already know some stuff. And then you just say, hey, like in this context, I'm expecting that result.
Yeah, and we can even see here, once we get into this form where we're creating a new project, it has this domain selector where you can actually specify, if you are training an image data set that is primarily based on food or landmarks or retail locations, instead of just starting with the general purpose machine learning model trained on everything in the world, you can start with a slightly more focused model, so you're going to get better results at the end.
Oh, totally makes sense. Yeah. Cool. Okay. So now we won't create one because you already have something running. So that's cool.
Well, I was going to say, let's create a new one anyway.
Okay.
May as well go through it, and because I would like to walk through and show just how easy it is to just add these images and then actually test this new model rather than dealing with the model that I already have. Let's build a new one and see that I'm not faking this. We actually can just generate this.
Excellent.
So we're gonna do classification. So basically, like the two different types of computer vision in this context is classification is is this image an apple or is it an orange? Versus object detection is much more about, yes, there is an apple in this image and it is at these exact coordinates. Or since all we really care about is this someone touching their face or is this someone not touching their face, we don't care about, if there are multiple faces, where are they? That sort of thing, like classification really makes sense for us.
Okay, so there's type. Okay, that's cool. Like that. Wow,
yeah.
That's very, like, for a different kind of scenario, you need to okay, that's cool.
Yeah, and then similarly, like you could imagine, so if the input to this black box is going to be an image and the output is going to be some data about what tags are found in that image, like in our case, our tags will probably be, touching face or not touching face, say. You can imagine scenarios where you want multiple tags. Like if you're trying to detect objects, there might be multiple types of object in there, or if you're trying to classify, not just is someone touching their face or not, but also what color is their hair or something like that. Being able to get back multiple types of data for a single image is really valuable. But for us right now, all we really care about is getting that single tag back per image. And then finally, for picking domains, as we mentioned, there are these sort of different areas you can pick. If you want to get like different sets of starter data, we really just want general. That makes the most sense for us.
Yeah, because the other are.
Yeah, the interesting one is the version of the app. So the version of the app that we're going to build now is one where this model is going to be accessible via an API. So you can make an HTTP request to Custom Vision and give it an image, and it will return you back some data. For the actual version of the app that is live, that wouldn't have worked. It's rate limited at a rate that we just couldn't make API requests quickly enough from a web browser to do that in real time from a webcam. Like this is clearly meant for different purposes than sampling a webcam every 100 milliseconds or whatever. So instead, the actual live version of the app is actually running completely in the web browser. we have a TensorFlow JS model that runs the machine learning model in JavaScript in your web browser, which is awesome and really cool. In order to do that, though, like the gigantic general domain that we're subtraining is way, way too big to like download to your web browser. So if you want to do stuff like that and run it in a web browser or on a smartphone or on some sort of embedded device, they have these sort of more compact models that are like the quality is going to be lower, but it is better for those purposes.
Okay, that's cool. And is it also, I know some service are available inside the container. So I'm assuming then like inside those containers is probably the compact version also that is available. Do you know?
Probably. I don't actually know.
Okay.
I could see it going either way. I don't know.
That's fine. But like it's definitely very useful to have a compact version for when you want to work offline or like want to like store it in a device
here, like,
or something like that. Yeah.
Yeah, like our docs are specifying like these are for real-time classification on edge devices. So I would expect, so like a desktop computer or a smartphone or something like that. So I would expect like if you have a container for the purposes of running it on cloud servers, like those are going to be powerful enough that you can run the larger model. So I would suspect for that purpose you might still want to use the full one rather than the compact one.
Sat here in the chat say compact mean neutral network. It's not as deep as the others. Basically, less multiplication because these less parameters.
Yeah, exactly.
Okay, it's cool. Thanks.
Yeah. Cool. So we have a new project that is asking us to upload some images. So if we go to our face training data, let's see if we can drag these on in.
Oh, seriously, nope, that easy? You just drag some images and...
Except we have to do that though. How do I actually... I am bad at Windows.
Go back to the window where all your images are.
Mm-hmm.
And then in the top, copy the path. Oh. That's it. Oh, there's quote, so you need to remove the quote.
Oh, pasted twice, that's why. Beautiful. And if we add all of these.
So we have a question in the chat from Camtam Sphinx. If someone is switching from TF Keras, I don't know, maybe it means something for you.
Like TensorFlow and Keras are two different machine learning tools.
Okay, and want to switch, what would you rate on 1 to 10 the difficulty they may face? Quantum physics. Oh, thank you. You see, it's not my specialty.
That's a good question. I think like these are tools that are operating at a very different level of abstraction. I think like something like TensorFlow or Keras, you're manually training the model yourself. You're setting all of the parameters that you want to tune about how many layers and all of these million settings that like, frankly, I don't understand as someone who like mostly uses these tools to build weird art rather than like diving into, training these models yourself. So if you want to switch from like training a model yourself on TensorFlow to do the sort of image recognition task to moving to custom vision, I think if you already have your images that you want to train on, what you're doing is basically going to look exactly like we are doing. I don't know if there's any sort of your other previous work you could build on, because like this is such a much more like guided process than manual training, if that sort of answers the question.
Hopefully, we'll see. Let us know.
Yeah. In the meanwhile, so we have these images. We could probably use the negative tag, but I'm also happy to just say we're going to call this not touching because you're not touching your face. So which means we're telling it we have these, like, when you are training this, like, these are, if you encounter an image that looks like these, that means it should probably have the not touching tag. And we can then upload some more images for our not touching. And you can see like a lot of these images are pretty weird and low quality, which I think for now is probably, even given this bad uncleaned up data, what kinds of results can we get? And so we'll call this touching. Cool. Yeah, I think one of them is an animated GIF that I didn't clean up, so it's not going to get added. But so we have all of these touching images and not touching. Okay, cool. And now what we have to do is click train. If you click advanced training, you will have much more options about like how much time do you want to spend training it, and you'll theoretically get a better model. For something like this, where we have so few images, this doesn't matter. Even setting it to 24 hours, it's going to finish in less than a minute anyway. Trying to train it longer than that with this few images would just oversample and give us worse results, so it won't even let us.
Yeah, because this is just a demo, but I'm assuming like in a real live situation, like it's important to have like a big pool of data as a source, right? Yeah, and we can talk through later sort of how I'm using a larger data set for the actual production version and where that data is coming from and how this training changes. I guess it's also just worth calling out, Seth is saying some great stuff in the comments around how we are showing off the very easy to use, simple high-level machine learning for dummies tool. Azure has the much lower level, like if you want to train your own models and you just want to train them on Azure cloud computers and run them on there, like those services are all definitely available and exist. I think we're just not really going to talk about them today, and that's not really like my area of expertise. Well, like it's not the purpose of the show either. So like,
yeah,
it's an introduction level show.
Yeah, and if anything, like I think it is a strength that like I can walk you through this and help build this thing without actually being able to talk about the underlying machine learning. I think that shows just how powerful this tool is.
Indeed.
So great, we have a trained model. It's going to give us some data that it claims it is absolutely perfect. So great, I guess we're done.
And wonderful. And now the chat is chatting by themselves. Excellent. Oh, and then we get raid. Oh
yeah, 97 new friends. Awesome.
97. Hey, so welcome, raiders. Welcome from the Visuals Talk Show. So. Welcome. How was your stream? What did you talk about? We'll continue. Well, like sometimes they had some. They need to see some ads before they could really join.
Yeah, that makes sense. Amazon's got to get paid.
Yeah, someone need to,
right?
Right.
So I guess. With this many new people, it might make sense to sort of step back and give a little more context than here, which is we have this custom machine learning model we have just trained about touching your face or not touching your face. For like the ultimate goal is the sort of app that I showed off where if you touch your face, it honks at you and yells at you and gets you to not do that. But where we are now is we have this Azure Custom Vision project that we have trained it with a whole bunch of images. We just uploaded 20 or 30 images to say, here is someone touching their face, here is someone not touching their face. We just got these by doing a Bing image search. And now we have this model that we are about to actually test. So if we do a quick test, it's going to ask us to upload an image. And I very recently took 2 photos of myself right before the stream. Mm-hmm, so if we upload the one... If I upload the one where I am not touching my face, it is 99.9% sure that I am not touching my face.
Wow, pretty cool.
Yeah. And now the real moment of truth, if we give it this one where I am touching my face, it is 99.9% sure that I am touching my face.
It is very impressive because,
yeah,
like a computer, an image for a computer is just pixels. Like, this is not a hand, this is just pixels. So, like, he realized that, yeah, you have a hand, this is your face. There's a bunch of stuff that we see in the picture. But he found the face, he found the hand, you see that the both are touching each other. This is pretty cool. Can he?
Yeah, and, like, if we go back to our training data, like, these are all professional stock photos on white backgrounds, nothing that resembles my potato webcam with a messy apartment in the background.
So what about a picture of holding a hands up?
Oh, that's a good question. I don't know if there is a good way for me to take a photo. Like a thing that I would love for this tool to add is just like the ability to take a photo from your webcam. But I suspect like most of the people who are actually using this tool are probably building out like they're building software where they're not intending it for you to use it from a webcam, so it makes sense they wouldn't bother. I wonder if there's a good way to do that.
Yeah, you're right. Electric say like it's even more than it's a bit stream. It's just like it's nothing.
Yeah, like RGB pixels.
Oh, and Seth said he made something like that.
Why?
I'm
awesome.
not surprised. Oh, he's sharing his GitHub. Is it a one-click deploy, Mr. Seth?
Oh, I think let's go skim through this really quickly. I think this might actually be, yeah. So I am actually using this project in the actual final version of the site, which it might be worth showing that off now, because that might be fun. Like we could either talk about that, or we could talk about, now that we have this functioning model, what does it mean to like make some HTTP request to actually hit this API. I'm not sure which might be more interesting.
At least finish this idea where we have like what's the result that is really returned. Like I saw like I'm assuming it's a JSON file that is returned, or like how like.
Yeah, so if you switch over, so I have like let's see what this looks like. I have an earlier version. So this is not the version of the web app that is running live. This was the earliest demo that I built. If we want to sort of walk through this code and talk about how it works. Mm-hmm. Actually, let me start a server running so we can load this up. Oh, that is not a good sign. Maybe we won't actually see this running live. Oh boy. Fail to initialize.
Cannot read property length.
Interesting. Let me make sure that I installed everything properly. Yeah, so this is all a JavaScript web app, just some HTML and TypeScript. And then I have some local tooling, like I'm writing TypeScript, so I need to compile that down to JavaScript and theoretically spinning up a local development server. So that, you know, if you want to use a webcam, you have to be running a web server. You can't just like access a file from your web browser.
Yep.
But that is not a good. Let me.
Or we could just look at some part of the code that you think are interesting, also like.
Yeah, that makes sense. So we're starting out, opening up a webcam is some boilerplate code. But
is
really
it big enough? Is someone want to have the code bigger? I think it's fine from my computer, but maybe in your screen is smaller, so we could zoom in.
I think it's always good to make.
You could Control Shift Plus also. I think if you want to have bigger text.
I'm just trying to remember how to close the sidebar.
Oh, type again on the icon.
There we go.
The first icon on the left. Yeah.
Or
I think Control B also will close it.
So if you look at our actual function, so this function is assuming we have already loaded a webcam. I'm gonna make this a little smaller so I can read it. It's assuming we already have an active webcam going, which there is some code here that just fetches a webcam. We also have to have some code that is a little ugly, so we can not really pay attention to it. That given a webcam canvas, we need to convert that into an image. So the way we have to do that is we have to create an HTML canvas, draw the current image from that video to the canvas, and then we can convert it to a blob, which is going to be the raw data stream.
Okay, because now you have a feed of image, so you're capturing one and like creating an image.
Yeah.
So
30 times a second or 60 times a second, we need to go through and say, here's the static image that we're seeing. Let's operate on that.
Okay.
And so then from there, so when you create your model, if we then go into, how do we actually find this? I think it's performance maybe. If we publish this, I won't necessarily click it, so I don't have to expose all my private keys and hope that and like get rid of them later. But if we clicked publish after associating it with a resource, this would give us a live URL and a live key that we can use to make API requests against this model.
Okay. Yep.
So if we did that, and then we just dropped that into, we're going to make an HTTP request against that URL. We're going to include that prediction key, and here is a blob image. It is going to return us some JSON. Let's look at how we are doing that here. So we have this function here that handles that response. So it's going to take in that image blob that we have gotten from our webcam feed, and it's going to ultimately, like, the API that I have designed for my own app is saying, this is true if you're touching your face, false if you're not. So we're going to make that API request. That's going to give us back JSON. We're expecting that to have a bunch of predictions, which are a bunch of objects. So in our case, I think it's returning what.
Do you have an example of the JSON document that is returned?
That's a very good question.
I know, right? I'm that good.
Yeah, I should have had this prepared.
But it's fine. I'm sorry. I'm sure at some point
I was
to build the code, you had like a question and took the result and like.
Yeah, like you can see here, we're just console logging it out. So conceptually though, since we have two different tags, it's going to return us two different predictions. So for touching and for not touching. Maybe it has some other metadata, but what's relevant to us is it's returning us a probability.
In the tag and the probability.
Yeah, so we imagine this will probably look something like, it's not on flip side. Oh, I didn't actually want to get those. But so if we have an array of one of them is going to be tag name is touching, and it'll have some sort of probability, call it 0.5, that'll be between 0 and 1, and then we would have another one for
we'll have a bunch of tags.
Touching.
So we'll have like a touching, person, office, something like glasses, whatever. No,
it is only going to include the ones for our custom tags. I think if you want that sort of general purpose,
that will be the other one.
Is there a human being? Is there a dinosaur? You want to be using a different service than Custom Vision. This is we are telling it for this model we have trained. All we care about are these two tags we have created, touching and not touching.
Okay, so like what I was explaining, asking was when you use the cognitive services like the vision, the basic one, the black box one that you cannot train, that's the result. It returned a bunch of stuff with like the probability of every affirmation, I would say.
Yeah.
I think in our case is just what we ask for because it's trained, because it's custom vision. Okay. Oh,
I think it's
cool
important
then,
that it's and then it's also specifically giving us all of them, because like if you just used like a regular vision API, it'll tell you that it found a face and it found a bicycle. If it went and explicitly told you we did not find a dinosaur, we did not find a sword, we did not find like every enumerable object,
that won't make no
that would be a lot.
Yeah. Everything that it didn't find.
Yeah.
very not efficient. How to write something not efficient? Tell me everything you don't see on that picture. A bunch of funny scenario in my head. Sorry.
Completely use up all of your users' phone bandwidth.
Yeah, exactly. How to take all the juice of your computer, run this app. It will tell you everything that is not in the picture. Well, that's pretty cool.
But yeah. So given we have this sort of predictions array that looks like this, and again, without looking at the actual data, these objects might have some fields in them other than tag name and probability, but that's all we really care about right now.
And the result we had when we did tests with your picture of your face, it was something like 99, right? So it's very, very good then.
Yeah, and so even then here, just to be generous, like the algorithm. So like, assuming your model is imperfect, the act of how are you interpreting the data you're getting back from it is itself an authorial choice, and like itself can have an aspect of like figuring out the correct algorithm. In this specific case, all I did is, this model is accurate enough. It's probably safe enough to say that if it thinks there is any chance you're touching your face, you probably are. So we don't even look at the not touching probability. We just say, if there's a 10% chance you're touching your face, great, we're going to assume you touched your face and play an audio file and do whatever else we want to do.
Okay. And like you mentioned a couple of times, like you're training images, like in the sample were like not very good in her case, but it still have like 99%. So yes, you're white. The picture were white people also, so that helps in her case. But at some point, will adding more images will be bad for the result?
I think it depends a lot. I think adding more images that we just got from being image search again, like I think we would very quickly reach diminishing returns. Again, not enough of an expert to say definitively, but I bet there would be a point at which it might actually hurt us, assuming these are all still stock photos. But I'm not exactly sure. For the more complex version of this, I definitely have not yet reached the point where the more data I throw at it, the better. So basically, the difference between this simple version and the version that is actually running is just this API that we are hitting. It has a rate limit of something like 10 requests per second, which this version of the app, I'm running this loop where we get the video frame and then hit the API service and whatever. We are doing that every 100 milliseconds. So if the API limit is 10 times a second, a single user using this is going to hit that API limit. So we definitely can't release it on the open internet for anyone to use, because 2 users using it at the same time are going to destroy that. Yeah. And we can up that interval, so we're running it less frequently. But for this sort of game-like experience where you want this immediate feedback when you touch your face, if we ran it less frequently, it's both not going to feel responsive, but also like you could touch your face in between the 2 times we ran it and quickly move your hand away, and it's not actually going to catch that. So we really wanted something that we could run more frequently.
Okay. Yeah, because like in this specific demo, you are really like in a, like it's a demo, like it's a specific thing you want and everything. Okay, that's cool.
Yeah, and so then what I ended up shifting to is, so when I said, okay, we can't hit the API frequently enough, we really want to run it in the web browser using TensorFlow.js. As I think I mentioned, the Custom Vision website can export to TensorFlow and all of these other sort of ways where you can run a machine learning model locally on a smartphone or an IoT device or in a web browser. It needs to be the compact model, because this huge model is like way too big and way too complicated to run on a device. So if we go to like the actual model that we're using, why is it not letting me? Oh, I don't know why it's not letting me find it. This might not be the right project. Maybe this one? Yeah, so if we go to export, it will let us decide, are we trying to use this with Windows ML? Are we using it? Do we need a Core ML model for a native iOS app? And I was able to go and say, no, I want a TensorFlow.js model, which will let me run it in the web browser. But what we found with that was this exact same approach of just dumping a bunch of stock photos that we pulled from image search. The quality wasn't very good, which makes sense that if what is so powerful about that first technique that we just worked through is that it has this gigantic data set of so many images, so it has a really clear idea of what a face is and what touching might be. If we're using a smaller model, it's not going to have that sense. So we really need more data, and ideally data that looks more like, people sitting at their webcam rather than, a stock photo.
Yeah, more contextual. Otherwise, you're training, but not for something that will match the result.
Yeah, And so what I ended up doing was, if we go to the actual app again, it's not going to load because we won't even try to load it because of the webcam, but I used this project that Seth built and adapted it, which basically, it is a tool for when you give it camera access, you press a button and it takes a whole bunch of different photos of you using it, and you yourself as an end user tag images and say, am I touching my face? Am I not touching my face? Is there no face at all in this image? And then there is I think if I actually took some photos, like a submit button would appear. And when that button is pressed, all of the images that you took and all of that training or all of the tag data get uploaded. It hits an Azure function, which in turn directly hits the Custom Vision API and uploads those images directly into the Custom Vision portal with those tags already in place. So this means I could take all of these people who are really excited to help use this app, have them send some photos of them touching their own faces and not touching their faces, and then I would end up with this exact project in the Custom Vision portal with this data already ready to go, so I could click train. I think the actual data that I'm using, if I go to untagged, we can see some. Yeah, so we can see people just, here's myself sending a bunch of images in with my head in different weird directions to try to throw it off.
Yeah, I think at some point you sent or asked on Twitter, or like, I remember sending picture of me touching and not touching my face. Oh, that's cool.
I should have tagged those with specifically Frank so we could then put them up.
I made fun of it a long time ago, though. But that's cool. I love it. Like it.
Yeah.
I agree now with. I don't know if you're still there, Seth, but okay, it'll look much simpler than I thought. Well, I'm used to use like the untrainable version of it. I know.
Yeah, like it's ridiculous. I still can't get over how easy this is and want to figure out what other weird things can I build on top of this.
Yeah. And feel free, anybody in the chat, if you have any question, this is a very safe place to ask any kind of questions. Always, like every second stream, I have questions. People don't even know what Azure is, and it's totally fine. That's a place to learn. The goal of this stream, this show, is to take whatever you know and bring it and help you to get started, build crazy app like this one, crazy in a good way, like exceptional thing. I think it's very creative and it's very easy. Like you just need how to make an API call and analyze the JSON file, and there you go. Like, you know, like there's more to make it pretty and everything, but you know, basically that's what it is. Pretty cool.
Yeah. And like the fact that you can run this in real time is also really awesome. Like it means you could imagine if we were using object detection instead of classification. So instead of just saying, you know, not you're touching your face, but you're touching your face here, you could imagine doing things like with the Connect, where we could even say, you know, hold up an apple on screen and like move the apple around in a real-time game. Like there's so much cool stuff you can do, and you can just detect images in real time.
Yeah. Now Vision API is pretty powerful. Like I found that it's one of the AI that I found very, very impressive, because it's so fast, and from the outside, if I can say, like it's kind of simple to use. I mean, like to consume. Like I know there's more advanced and like more complicated, and like you could do a lot of stuff, and we have like those services in Azure. And I worked in a place before where like there was like a bunch of data scientists and professor and rocket science and a bunch of people like that. But I could use those kind of services right now, like that we're talking today, without being an expert in those. And so I could build an app. There's plenty of application where I could be using that in an existing application, adding some functionality. And we did something a little bit where for Ignite last year, we had like so you could take a picture of, let's say you want to buy a cup, like a coffee cup, not like a police cup. Then you take a picture of that, and it will show you any matching cup inside the inventory. So that was, done also with but I think it was done with the like the just vision though, because it was classification, like you said, like with all the tags. But yeah, that's pretty cool. So you mentioned then you're working on a similar project right now with Seth, with like the other project that he showed in GitHub.
Oh, so this tool that I showed off
So
that
it's that
lets
one.
users upload their own data. This is using Seth's code base.
Okay. So that's the one you mentioned earlier. He's trying to migrate it now to use the sorry, my phone is distracting me, and he successfully did it. He's trying to do what was saying it was
move it to Azure Static Web Apps.
Okay.
Yeah, which is nice because this app here, like, the deployment is automated, but it is still like there are a lot of moving pieces because you have Azure Blob Storage static website hosting, and then it also has Azure Functions, and those talk to Custom Vision. Whereas like using Azure Static Web Apps, you can have a single resource on Azure that is handling both hosting the static website and also having an API via Azure Functions. It is sort of just a more cleaner and modern way to host this sort of thing.
Seth says it already made it work. I just need to update
nice.
the README. Now he's just showing off now. So if you didn't understand, Seth is part of our team, so we're trolling him a little bit. Now he's showing me the GitHub to prove me
the exact code. Like, yeah, it works.
It works. Look, Frank, it's working. This is awesome. I need to do something like that, automating an app that I'm building using a static web app and the API. Cool. So no question at all. I'm surprised that the chat is just like, I was the only one not knowing how Custom Vision was working. Wow.
It's just so easy to use. There's nothing to wonder about.
It was a show just for me. You have anything else you would like, some gotcha when you did deploy that thing, things that, I don't know, didn't work the way you expect, some trouble? You mentioned earlier that the speed, you hit some limit, some threshold in the API, but that was because you're using the free version, the free tier.
Even the paid tier has rate limits on that. Like, it is clear that it is not the REST API hosted version is really not meant for this sort of real-time use, which I took as a sign, like, great, I am working against the grain of this tool. Let's figure out a more appropriate way to do it. And if you think about it too, like, it makes a lot more sense that if you're going to be analyzing webcam images 60 times per second, you probably want to be, like, it wastes a lot of bandwidth to send, your webcam feed 60 times a second up to a server and then get a response back. So running it in the browser is also sort of friendlier to users, especially if people have data caps or are on slower smartphones. So it like resulted in a better project than if I had been hitting the API the whole time, which is cool. I think like the biggest gotcha was once I switched over to the compact models, realizing that the previous approach of just image search wasn't going to cut it, and that we really needed our own training data, and that we needed a lot of training data, and making sure we had people who are different distances away from their webcams, and people with different lighting setups, and people looking different directions.
Yeah, different angles. If you're using a laptop, so like your nose is not the same position as like us right now.
And I think I mentioned, let me check out. So the code we were looking at was like an earlier version of the code. An earlier version of the code that was using the API. The current version of the code, the way that if we look at what the sort of detector now looks like, so this is going to be a little different than the other one, because instead of making an API call, like there's some boilerplate code to load a TensorFlow model and to sample it. That logic lives elsewhere. Because the data is much noisier, there actually is a bunch more logic in JavaScript to figure out, like, given a set of probabilities, are you actually touching your face or not? If I can find where this code lives. Right. So the ultimate algorithm per se that I'm using is, oh, hello. Where did that algorithm go? So it only counts as you touching both if the probability that you're touching your face is over a certain number, but also the probability that you are not touching your face is below a certain number. And a lot of these specific values, like the only way I could get these was by hand tuning, like me running it with printing out those values and moving around and touching my face and not touching my face and figuring like what is the sweet spot of these values to actually give me the result that I wanted.
Okay. That's cool. So like the code is still very active. So if someone is interested to learn more, so I'm just looking at I will butcher your name, Old Astrav Divorce. He's learning right now those kind of the things. So meaning like if he's looking in the GitHub repo, those things are really active. You're just updating the one who takes picture. That one you're just doing a new version of it. So like those GitHub are very alive,
yeah,
if I could say.
Yeah. Like I haven't touched it in a little while, other than I added a README today and a little more instructions for how to get it up and running. But that means, if you clone that GitHub repo and install some dependencies, you will have a version of it that works immediately locally. And it has the exact model that I'm using on the hosted version. And so you can play with that. If you wanted to load in your own model, you could go to Custom Vision, train up your own machine learning model for either touching your face or for any other image thing. And you could drop that image or drop that model right in here. And other than the fact that it is pulling a model file from disk, that is all that it really cares about. Everything else is like you could drop in a different machine learning model and it would work.
I'm not messing with images, but that's really cool. Like I'm sure, like if you have any questions, feel free to reach out to M Laser Walker. The Twitter is just under the video feed. I'm sure she'll be happy to help you or redirect you to some documentation.
Yeah, and similarly, like it is like I've done some work, like we're talking all about images now, but I've done a bunch of work with like procedural generation and things like GPT-2, like at a same level, still just messing around, like not a machine learning expert, more an artist trying to use technology to make weird art, but seeing like what are the different ways in which we have these out of the box machine learning tools to do cool things.
Did you see the dark corner cell? So he's messing with picture and it's really cool. Indeed, oh, nice. It is. Did you see the art? Forgot his name, from Germany, the new cloud advocate. Well, new, like not anymore. I mean, he's been in the team I think for 6 months or something like that. But he's doing art also, like merging kind of some images.
Huh? I haven't seen that.
Yeah, it's super cool. Like let's say it takes 20 picture of you, and if you have kids, and like merge everything, and it generate like a different face. It's very interesting. It's very specific, not like a little bit strange. Some people say creepy. I don't find that creepy. I find that very interesting, because like there's some pattern that the AI found and merged them. It's really cool. I forgot and he document everything. I need to find out after the stream. I will take a notes and I will let you know, because that was pretty cool.
Yeah, like I love, like it is one thing for a machine learning model to be able to like recognize input. I think it is so much cooler when it is actually generating new output. And given how like at a high level all of this quote unquote machine learning stuff, the techniques aside, it is sort of very sophisticated statistical analysis and just like recognizing patterns that are already implicit in things that we maybe take for granted. And so when it can actually take our own assumptions and generate new things back at us, I think that is really revealing about our own biases and assumptions that can be really cool and interesting. Like whether it is taking two faces and merging them together, or trying to generate poetry or anything like that.
I said Germany, but it's Russia. So it's Dimitri.
Oh, Dimitri, yeah, cool.
Yeah, Dimitri Shimiskov. Yeah, he did a bunch of stuff, and yeah, that was pretty cool. Like, he did a demo. I think that was at the summit. Anyway, I know he wrote a nice blog post about that and everything. It was super interesting. Oh, I saw new stuff in the chat. I'm thinking about doing something for math exercise. Oh, that's cool. And I was thinking about using recommender system like they do with movie site and things like that. Is that a good idea, or is there something better?
If your goal is to generate infinite math exercises, I suspect, like, depending on how you do it, I suspect you may want something a little more handcrafted, just because computers are very good at recognizing the broad shape of things. But if the goal is to, like, have something that exactly has a complete answer every time, that might be tricky. A model, like, not machine learning at all, but a thing that I am mildly obsessed with are spaced repetition algorithms, which is, so they're like, if you ever use something like Anki for flashcards, or like Duolingo, the language learning site, uses these, like, the algorithm is basically the way that human memory works. Like, the way that you learn something is if you practice it now, and then you practice it, tomorrow, and then 3 days from now, and then a week from now, and getting the sort of exponential decay is like the actual best way to remember things. So there are very specific algorithms that, given, a bucket of flashcards, here's the way you sort of shuffle your deck of flashcards and present them to users. And if someone gets a flashcard right, when do you show it to them next? Versus if they don't get it right, when do you show it to them next? And there's a service, what's it called? Gary Bernhardt runs it. It's called Execute Program, that is like a learn to code platform that actually uses this exact technique. So if you go there to learn TypeScript, say, there are a whole bunch of lessons, and you can pick which lessons you want. And the two things it does is it dynamically decides which quiz questions to give you based on how well you're doing. But then it also has this sort of knowledge graph of, you can't learn this lesson until you've learned all of these other lessons. And it sort of gives you your own gated, like, personalized learning study based off of what you have already learned and what you are good at versus what you're bad at. And I don't think he's using any sort of quote unquote machine learning. I think it's a combination of the spaced repetition and probably sort of like building up essentially a state machine or a knowledge graph of what an individual person knows. It is Execute Program, I believe, since you're asking for a link.
Yeah, I was about to ask you, but
yeah, that is it. Yeah, I haven't spent a lot of time with Execute Program in general, but Gary's work is generally phenomenal. I used to watch his, like, Ruby on Rails screencasts. Maybe you've seen, he made the, like, famous JavaScript WAT conference talk. That's like a hilarious 5-minute talk about how silly JavaScript is.
Nope. I didn't see it.
It's great.
I have
it talks
nothing
about
against JavaScript, but
I mean, like, he makes fun of JavaScript, but lovingly, in like the same way that every language has the same bits of silliness. Like, at the edge of, like, in JavaScript, if you add a number to a string, the result depends on whether the number is first or the string is first, and either way, it is not what you expect. Like, JavaScript has slightly more of these silly bits than most languages, but every language has them.
Yeah, I rediscovered those kind of gem recently. Like, I had nothing. Like, people thought like I was like against JavaScript, or like, I was like, no, just like, when I joined the Cloud Advocate, there were a bunch of already very good JavaScript Cloud Advocate, and I was like, well, I won't start learning JavaScript because, I'll do something else. But now, like, I'm building a bot, and right now, like, there's no AI, but of course they will have some AI eventually in it. But a chat bot for Twitch, and I did it using JavaScript just for fun, so I could learn and have a different point of view. And I'm suffering because it's very different than .NET.
Oh, yeah, that's for sure. Like, I'm curious if you played with TypeScript, because I find like that does a great job of bridging the gap for me.
Yes, like, and everybody's saying when I say that, oh, I use TypeScript. I said no, because I really want to learn Node. Like the first time I created the thing, like I had no, of course I knew I needed Node and NPM, but I didn't know how to start a project. And so I was following the chat.
Yeah.
I was following my, I call my community Cloudies, because you know my stream is always about cloud stuff, and so I was listening to Cloudies as okay, do this and okay, and I can in one stream, so 2 hours, we had a chat, like a bot chat, had like doing action inside my Twitch feed. At the second,
cool.
Yeah. So now, like, I've just been working like a few hours on that, and now like it's displaying images, playing sounds, keeping high score on a game, like doing a bunch of stuff. So it's very, very cool. I'm having a lot of fun. I'm using different framework. So right now I'm using Comfy.js, like it's a framework done by Instafluff. I don't know if you know Instafluff.
I don't think so.
He's doing a bunch of JavaScript game and super funny guy. Anyway, so I'm using one of his. I don't think it's a framework. Framework is not a good word. It's a module, I think. You call that a module or something like that, or package, whatever. I think it's a module,
library or a bundle of code.
Yeah, a bunch of code. You use that, and then like just I wanna chat, and like boom, like then you catch a bunch of interaction with your stream, and like you could play with that. So
cool.
Is it pretty?
Are you in terms of like an AI-ish angle? Like, are you doing? Does it give you sort of like an intent model like you would see for Alexa or Google Home, or are you just like manually going through like a string yourself and looking for keywords, or
so
how does that work?
Right now we're just building from scratch. So right now, the event most of the event are catched by whatever module that was there. So I have like on command. So every time someone do in the chat like exclamation point something there, that's a command. So that will be triggered that part of the code. So then based on that, I could check that. So my code right now is looking for specific...
I cannot hear you anymore. I think Microsoft Teams ate my audio.
Can you still hear me, chat?
Okay, there. Now I can hear you.
Anyway,
cool.
So I have fun. Like I will share the GitHub to you if you want after.
Yeah.
This is not the... If you are interested, come join me Friday. Friday morning. Well, that's on my channel, F Boucheros. That's where I stream. I play with I play with that. But right now there's no AI, like no real AI right now. It's just like I'm.
Yeah, that's a lot like. So I organize a conference about game development and procedural generation called Roguelike Celebration. Mm-hmm. And this year we are, instead of using Discord or some other hosted like event platform, we're building our own custom like text-based game and social space for the conference to take place in.
Cool.
But it means so like you're mostly typing into a text box, but if you want to like move to another room, you can type like /move that room name, or like you can there's a room where there'll be like potions, and you can like mix potions together and get other things that'll have effects in the chat. And so there's a little bit of that same sort of like language parsing of as we add all of these different commands, how do we distinguish chat from that, and how do we like manage these different commands in a way that's not going to be completely unwieldy.
That's really cool. That's really cool. We still have plenty of time. We still have like something like 15 minutes. Do you have anything else you would like to show us? Another project of yours?
Yeah, so a couple things. I could either show off that sort of social space, or I could show off like maybe it is a little more like exciting, and maybe sexy is not a good word to use. But like, so Microsoft Flight Simulator comes out today. Actually, yeah, let's talk about this.
Yeah, let's go. We'll go like, back in your... It was only us. So yeah, that's fine. I see your screen now.
Let's see. Oh, I don't know if I can run this without a VR headset, Ronald. We'll see. So Microsoft Flight Simulator comes out today, and it's like big magic thing that it does is you are just flying in the world, and you can fly literally anywhere. And the way they are sort of hacking this is a combination of, a lot of areas are using Bing 3D maps data to just load a 3D map of the world. Some areas are using more like they're taking, satellite imagery and deciding, how to render it in 3D based on that. Some of them are hand authored. But I looked at that and said, what if like anyone can use the Bing 3D Maps API? What if we built our own version of that where you can just fly through the world and like pick a city and see a 3D map of it? So I have this demo. I think I actually need to put on a VR headset in order to run this. Let's see if we can. I think so. I'm also using Mixed Reality Toolkit, which is so actually before I run it, we can step back. This is a project that's built in Unity, where I'm really just pulling in and mashing up two different libraries. One of which is this Bing 3D, like Microsoft 3D Maps library, which like drops us. If you're not familiar with Unity, this is sort of like a 3D scene editor that is showing us, abstractly what is this world. And so the Bing map SDK gives us this like square that we can render, here's a latitude and longitude and a zoom level, give us a 3D map here. Cool. And then I'm also using the Mixed Reality Toolkit, which is an open source project that Microsoft Mixed Reality maintains.
And if you want to learn more about that toolkit, you could watch the episode of yesterday, or soon on allroundazure.com. You will have all the URL for the previous episode, because we did a bunch of stuff with April and yesterday with Azure Cool. And we are using that framework.
Awesome. Yeah, MRTK is amazing. And like that's a big part of how like this demo that I was able to put together in a couple hours like looks so good. Which, let me see if I can spin this up. Oh. I love how ridiculous and cyberpunk it looks to like watch someone use VR hand controls when you can't actually see what they see.
No, you don't look ridiculous at all.
Come on, it's not recognizing my hands. I need to grab a controller. I was not prepared to give a live VR demo. Okay, I think I might be
in Premiere chat.
Yeah. I need to confirm.
Like I like to say that, but that's how you know it was not recorded. It's alive.
Yeah. Okay, cool. I think this will work. I need to be wearing the headset so I can control the view, but you should be able to see what I am seeing in Unity as soon as this loads, which is it's going to load us in.
Yeah, well now
here we are in beautiful San Francisco. There's the ferry building behind us. And we can move around. We're moving towards Coit Tower and Telegraph Hill. We have North Beach on our right. I think the idea will eventually be to give you more free control.
So like you're a bird in that thing, or like a
plane? Yeah, I think the idea is you'll eventually be like a plane, and you can more freely move around and move up and down and fly around instead of like this demo right here is just you moving on a static path.
Wow.
Yeah.
So
I think
they generate the map based on whatever data they have, and then Unity use that to build a 3D environment, or
yeah,
you building it?
Bing is the one who built the 3D environment. I don't know exactly how they gathered all this data. I think some of it may have actually been like Street View style cameras on cars, because this data is only available in some cities. Like I picked San Francisco because I knew that would have good data. Like Seattle has good data too.
I don't know why.
And so Bing is generating all these 3D images, and like if you use the Bing app on Windows, you can look at these 3D maps. They expose it through an API where I guess you can ask for meshes. But this Maps SDK, like Unity plugin, it just handles it all for you. You can enter different latitude and longitude, and it's handling streaming down all of the 3D maps data and constructing the meshes and the textures and rendering it in Unity for you.
Wow. It's very impressive.
Yeah, so like it's ridiculous. Like the quality is not as good as Microsoft Flight Simulator because they are doing a lot of really complex algorithmic work. They are not just pulling data down from Bing. They are pulling it down every 2 weeks and running it through their own procedural generation processes to clean it up and do all sorts of stuff. Um, but the fact that one person in a couple hours can build something like this is pretty mind blowing to me.
Yeah, no kidding.
And like again, like I didn't hand author any of this. Like if we popped in latitude and longitude coordinates for New York or Seattle or anywhere in the world, it would just stream in full rich 3D models of that.
Is it long?
Hmm?
Is it long to render that, or it's like a few seconds?
Yeah, like happens all in real time. Like you saw there was like a 2 or 3 second delay before it initially started up.
Then we could try New York or something like that.
Yeah, if we can grab some New York coordinates. I guess I should be using Bing Maps as well instead of Google Maps. But get a Central Park. Oh. Let's. Oh, I don't know which direction we're gonna go because right now the direction that we're moving is sort of hard coded. But if we pick like a central point in Central Park, that might give us some data. So if we grab that half of the coordinate.
Yeah. Indeed.
And we grab this.
Say, kids these days will have a lot of fun with those kind of games. Yep.
Yeah. Like I'm really hoping that like the company behind like Asobo, the Microsoft studio that makes Microsoft Flight Simulator, like I'm hoping they license like their specific more advanced technology to other games. But yeah, you can see this already loaded in New York. If we hit play, we're gonna get another real-time fly through of whichever direction I have it hard coded to move us. Like, oh, I'm about to hit that building. Oh no. I think we're headed off into the water, but you can see an ugly version of Manhattan disappearing in the distance.
An ugly version of Manhattan.
Oh wait, did we hit New Jersey or Brooklyn or somewhere else? But yeah, so the way this is rendering in real time, like if we look at this Unity scene, the way the code actually works. So me, the player, my camera is staying totally static. We are just moving like actually if we hit play and then if we look at the scene rather than the game, the like all we are doing is changing where the map is pointing at, and so we're streaming in new Bing map data in real time, and we can see how quickly and seamlessly that's loading in.
That's even more impressive, strangely.
Yeah. Like I suspect, like me just running this myself, I have not hit up into any limits of the free tier. Like I suspect, I don't know how viable it would be to actually ship a game that is hitting this in real time. I think there's a very like even separate from their algorithms, there's probably a good reason that for Microsoft Flight Simulator, they're grabbing Bing data every 2 weeks and loading it in a form in a server that's very easily cacheable and sort of much more scalable to millions of players. But for a quick and dirty demo, whew.
Yeah, it's really impressive.
Yeah, and again, like I'm not sure exactly.
Well, no, it doesn't feel like there's 3D anymore.
Oh yeah. I think we've reached the point where there is no longer 3D data. There is only. Yeah, we can see the hard edge there where there is 3D data and where there's not. Fascinating.
At the horizon, it looked like a train, just like trying to exit the frame. That's pretty cool. Thanks for showing us that. That's cool.
Yeah,
I love it. I was not aware that this thing was coming up.
Yeah, I think I'll have a lot more on this sooner. Like once I get to a point where, it is something I can distribute. I'll have maybe a Twitch stream or some videos or some tutorials walking through, how exactly you can build this. But it seemed like.
So you're streaming today, in fact, every Tuesday, later today.
Every Tuesday.
So if you text something in the chat, then people will have your address, because it's with your account, right? It's not on this channel. So if you find Laser Walker, the chat is she just said hi in the chat. So if you go on her channel, she's streaming every Tuesday. And is it the kind of things you're building? What kind of project right now are you building on your stream?
So every Tuesday, and I think we're going to add a second day a week. My coworker Aishagul and I are working on learning Unreal Engine 4. So like we're using Unity, which is like in here, which is a very popular 3D games engine. Unreal is sort of the other really popular 3D games engine. And both of us know Unity, but not Unreal. So we're starting by working through some tutorials, and then the hope is like we can sort of reach the end of those and spread our wings and fly and come up with some own project of our own to build together. And then I also stream sort of irregularly, 1 or 2 times a week around various other projects. Like I've been doing a lot of work on that like social space that I was talking about, and adding things like accessibility testing and text to speech and speech to text for voice chat and things like that.
Nice. So like that's perfect. If someone want to learn more, get started, that's perfect timing to jump in and follow you. Stay with you. Oh no, that's cool. And so Sapai01 is saying like using AI to avoid touching your face, and he's laughing because now we're talking about flying and stuff. Yes, we did build that apps and look into the code, but we had a little bit more time, and this thing was just released like the some service or like the fly simulator. Is that how it's called?
Yeah, so the game Microsoft Flight Simulator came out today actually, and so like a lot of people are really excited about it and super excited to like dive into this 3D map stuff. So it seemed like an appropriate time for me to be building out, how can you do that sort of 3D maps work in games yourself?
So that's why now we're talking about something else. So you're correct to laugh, but we did cover the topic of the day. But we're just chatting right now. The chat was quiet. You were too much captivating us today. It was a quiet chat. So
I talk a lot. Hopefully I gave people room to chime in and they didn't feel they were interrupting me.
Yeah, no problem, Kantem Physic. Now I can read your name. Like I don't know, I'm super bad reading the names. Like I read it once and like I don't understand, and at some point just like the letters fall into places and I can read it now.
Yeah, and I think even like there's a performance aspect of like feeling like you're being tested live on stream.
Oh yeah, there's also that, and like I'm always scared also that like there's people who troll, so they have like a funny name, and if you say it loud, then like you're not family friendly anymore. So always try to decode it every time. Like will I say something stupid if I say it out loud?
Maybe the next machine learning stream is how can we read all those usernames using computers and try to warn you that someone is an appropriate username. Oh
yeah, okay. I challenge you to do that for me. Or should I do it? Let's build that. We should collab on something like that. That would be cool.
Yeah.
Well, thank you a lot for spending time today with us. It was super cool. I think. Very inspiring to build a bunch of stuff with AI. Definitely, what's the word I'm looking for? Like I'm not afraid anymore of the custom vision of it. Like I knew custom, that was easy. The custom now is also approachable, I think, definitely. So very cool. Thank you for all of you in the chat. It was super nice. Thank you for the questions. Yeah. Thank you for Seth to share all his GitHub links. And knowledge also, very appreciate. And tomorrow at this channel, there's Clarkio and Cecile will be talking about Python. So feel free to join to learn more about Python. And with that, I will say have a good day. Bye everybody.
Bye.